According to the Nokia Future of Connected Building report, the multiple dwelling unit, or MDU, segment represents 46% of the addressable European market. But for multi-tenant properties, it's cost prohibitive to replace coax in building and also to do 5G antennas for each apartment. So service providers can reuse existing in-building connectivity, leverage infrastructure sharing for multiple subscribers on a single 5G link, as well as real-time telemetry and automation. And that leads us into our demo solution of Incognito service orchestration and device management, integrated with industry-leading partners like Nokia for 5G and InCoax for MoCA, putting into action Broadband Forum standards USP-TR369 and WT507. Service providers now can launch a lower-cost multi-gig solution, increase their competitive advantage against current traditional service providers in the MDU market, and also provide value-added services in smart building solutions like IoT, utilities, and HVAC automation to property management and real estate developers.
A couple of years ago, we started a work in Broadband Forum. It was called Working Text 507, with the objective to solve the connectivity issue when it comes to 5G millimeter waves. 5G millimeter waves attenuates up to 45 dB when it goes through a wall, and it is not sustainable to set up so many base stations to cover one MDU from 4 different angles. So we started to look how could we do a standard architecture that where we use existing components in the network, not create any new protocols or such, but see how can we combine different type of technologies so we can use the 5G as a communication pipe to the building, and then we reuse the in-building networks, either it's copper networks or coax networks, to get the connectivity to each of the apartments. And this took about 2 years to discuss and agree on what is the best way of doing it. And now, a week ago, we announced the TR507, and now we have that on show here in Network X Paris.
So an important aspect of this demo is the millimeter wave connection. So the 360 high gain antenna can support 2 gigabit per second up to 9.6 kilometers with optimal performance up to 2 to 3 kilometer performance. So you have this is inactive module, and the active module is shown there, degraded. So what we're showing here is about a speed of 3 gigabit per second, which corresponds to 2 kilometers. Now this optimal performance can be reached in line of sight conditions, and that's the reason why we would like to put it on the rooftop of an existing MDU. And then the signal can be converted there to the wireline technology. Can be Ethernet, can be coax, can be twisted pair, fiber even. Doesn't really matter for this standardization. So what we're currently showing here are one home connected over Ethernet with 2 homes connected over the MoCA technology of InCoax. Right. So now the important part is how to manage these homes individually, because as a fixed operator, you would like to see them from the BNG directly, and then can discuss more about this.
In the standard, it was very important to use standard interface so that the time to market for a service provider using the solution is immediate. So in the standard, we make sure that the existing interface for the BNG are reused. Right here, the standard also allows you to innovate where you can. So what we have is that the 5G UPF and the BNG are integrated in the same physical element. And what that allows you is to individually manage the home using existing standards. So the existing interface for the BNG is AAA, and that means that there's no new investment on your IT infrastructure. You can manage the wireline and wireless subscriber the same way. You can put a SLA policy per home, and in the demo, you can see that we have a different bandwidth tier that is applied per home.
One of the challenges in existing MDUs is how do I reach each apartment? And one alternative, of course, that you can pull new cables. You can make construction work, but the one more attractive way of doing it is to reuse the infrastructure which is in the building. And in principle, there is 2. One is the twisted pair, which has certain capabilities, and then you have the coax network. And since coax networks, the linear TV watching is going dramatically down, so there is a free capacity in this network. So the best way to get the gigabit and multi-gigabit connectivity is to use the coax network. And the part of here is that we have a DPU here which is communicating to modems in each apartment. And this can be built for point-to-point connection, or it can be built for point-to-multipoint connection. So it's a very smooth way. And if you want to go further on to fiber connection, you only take away the connection from the FWA modem and connect it to a fiber. So it can scale both for fiber connections and for FWA connections. So it's a very flexible solution to reuse in building infrastructure.
So the role of Incognito in this demo, we are using our digital experience solution to check the quality of experience that the end users are getting. We are checking, we can have a look at individual devices and individual homes to make sure that the speeds, that the service that they are getting corresponds to what they are expected to do. We can do that on real time and execute the checks on demand, but we can also run, let's say, general ongoing campaigns to measure periodically the evolution in case there are potential problems. And we can do that for the individual homes, but also take the information coming from them in order to get a general region level or global level metrics for the operator, which are potentially very, very interesting. We are showing this here, including the results in different point in times, in the different elements, both in the homes, and also the ones that are restricted get a lower speed, and also even in the main gateway that is getting access to the whole thing, and that has much higher speeds, obviously. We do this from using our USB controller via Broadband Forum tier 369, and also using the whole solution family of speed tests. In this demo, we are doing tier 143 for TCP/IP speed test, but we also support the newer version, tier 471 for UDP speed test, that gives even additional information that can be useful. So yeah, and in this case, we can see the two MoCA devices that are connected. They are polished at different speeds. In this case, 350 for one of them, the red line, and 150 for the purple line. These are the values for the download. In the right, we have the values for the upload results, which are more varied. And then we have a device that is connected directly via Ethernet, which is polished at 1 gig. And we can see the blue line showing that information. And we can also see the main gateway, let's say, that is obviously having the full bandwidth, and it's around 3 gigs in this case, based on the fixed wireless access speed.
And the 100 and 300 MoCA is kind of a service level that the provider wanted. Yeah,
they are polished. They are configured to be at that particular speed based on what the subscriber has purchased, the type of service that they are running.
Well, we want to thank Broadband Forum for the opportunity to collaborate on such an innovative standard. I think it has been a highly successful endeavor from all of us, and happy to see you again next year.